Hello and welcome back to my channel. Today we're going to be talking about volume, but things that are not quite cross sections for what we would know. So everything that we did with cross sections was had a flat base, and then we had cross sections coming kind of out at the top of it. What we're going to be talking about now is what if we took some two-dimensional graph and rotated it around an axis of revolution to get a three-dimensional shape. All the cross sections we would be seeing at that point would be disks in our case for this first part. So these disks are like cylinders. So they're like little mini cylinders that we can kind of take chunks of as we go. So if I think about the volume of a cylinder, it is pi r squared, pi times our radius squared, times whatever our height is. In this case, we're going to call our height a width because it's the width of this rectangle that we have here. So if we take something like a rectangle and rotate it around this axis here, we're going to get this disc shape that forms because it is now taking this rectangle and rotating it around. We can do the same thing with shapes that are not just rectangles. Any graph, we can rotate it around an axis. If we rotate it around the x-axis, it is a horizontal axis of rotation. If we rotate it around the y-axis, it's a vertical rotation. Both of them are going to use the exact same equation, minus x versus y and the bounds. So if I rotate my function here, we're still going to do pi times the radius squared, or radius being the distance between our axis of revolution to our function. And the width here is going to be taken up by our change of x, or dx. So our formula for disk method is going to be our volume is equal to pi times the integral from a to b of r squared dx. So the big thing that we need to find is the radius, or the distance between the axis of revolution and our function. The same thing goes for when we do vertically. We're just looking at that distance in that right minus left format. So we have find the volume of the solid that results when the region enclosed by the curves is revolved around the x-axis. So our curves this time are y equals x squared, y equals 0, and x equals 2. So we're looking at x squared, which is that parabola here, y equals 0, and x equals 2. So this is going to cut off everything except for this shaded region. So what we know is that our bounds, we have y equals 0, which is this right here. They're cutting that part off so that way we don't have some area down here that we need to worry about. Our graph, those two intersect at the same point at 0, 0. And then x equals 2. This is important because that's going to tell us our bounds. So we have a is going to be 0, b is going to equal 2. The other thing that we need to know is the radius of our shape here. And our radius is going to be this distance between our function and the axis of revolution, which happens to be the x-axis here. That distance is going to be everything under our parabola between these two bounds. Our radius is going to be found by using that equation, because our equation x squared gives us that distance between the x-axis and our function. So x squared is our radius. So if we plug that into our formula, we have volume is equal to pi times the integral from a to b of r squared dx. We have pi times the integral of 0 to 2, a to b, of x squared, which is r, but we need to square that, dx. So this right here is going to be our equation for our disk, or these disks that are happening at this particular case. So depending on what we have, we may use a calculator to do this. This one's not too bad because it's one term. So I have pi, the integral from 0 to 2 of x squared. Squared is the same thing as saying x squared times x squared, which is x to the 4th dx. I can integrate this to get pi times the integral or antiderivative of x to the 4th, which would be x to the 5th over 5, evaluated from 0 to 2. We're going to go ahead and plug this in. So I have 2 to the 5th over 5 minus 0 to the 5th over 5. So I have pi times 2 to the 5th is 2 times 2 times 2 times 2. Maybe another one in there, but it's 5 2's multiplied together. So if I do that together, that's going to be 32 over 5. 0 to the 5th divided by 0 is, or divided by 5 is 0. So I have 32 over 5 times pi, so 32 pi over 5. I could figure out what the decimal is, but we're going to leave it like this for now.